Now we're going to talk about the history of combustible fuels. So we have to start off with the basics or the beginnings, and that would be wood, which is cellulose, which is carbon and hydrogen, and charcoal. So um, these were up until the early 1800s. Wood was the main energy source or fuel. So it wasn't until the advent or the use of coal. Coal made a huge difference. Coal had just a higher energy content, energy density, and we could say that it fueled the Industrial Revolution. So by 1940, 50% of the United States energy was produced by coal. So this just shows you that we had a big turnover in terms of where we got energy, and coal was one of those. So what is coal? So if we look at an example of coal, it's going to be a large hydrocarbon. So again, carbon and hydrogen. We're talking. So if we're thinking about so these natural gases, methane, propane, butane. These are all very small carbon chains. So carbon 135, that's very large. We have 96 hydrogens. And then there's two other compounds, oxygen, or three extra, nitrogen, and sulfur. And so just to point out some of these, so what makes different types of coal unique is that we can have, we want to have, so coal, the best coal is the one that has the least amount of oxygen in it. So coal, we want minimal oxygen. So as we increase the amount of oxygen content, we decrease the energy content of the coal. So we want to look for coal that has not a lot of oxygen in it, which seems a little weird if we're combusting it with oxygen. Oxygen is definitely a part of it, but not. We don't want it in our combustible, in our fuel. And you'll also notice we have a couple other compounds, specifically sulfur. You might have heard something called acid rain. And this comes from H2SO4, which is sulfuric acid. There's no E there. Sulfuric acid, among other types. Sulfur can make a couple different types of acids. But basically, sulfur go up in the atmosphere, and then it would interact with water and oxygen and create basically a sulfuric acid that would then can rain down. And so this was a big problem with a lot of coal being being burned, and then some of the byproducts, besides carbon dioxide and water, were these sulfur-containing compounds. So sulfur is not good, causes acid rain. So again, one of the byproducts, and we saw a lot of soot that came out of the Industrial Revolution, a lot of pollution. So that's coal. Some of the other cons. So some of the, I guess, the pros. Well, let's look at the cons first of what made coal not the greatest. It was actually dangerous, still is dangerous to extract in general. If we look at energy sources, solids are harder to extract. Not only are they harder to extract, but also and to move around. Um, and the reason is, if you think about it, you can't make a pipe. Pipelines are the most efficient way to move anything, and those can only be used for liquids. You can't have a pipeline for solids. So solids have to be physically extracted. They have to be moved and hauled around using bulldozers and backhoes and trains or ships. And so they can't. You can't just use gravity to move them around. That's kind of like free energy, free work. Not that that's actually a thing. These quotes there. So solids in general, whenever you're extracting a solid, a lot more energy work. It's also a lot more dangerous because of this extraction and the chance of having coal fires, coal explosions, things like that. So it was dangerous to extract. That's one. There were a lot of environmental hazards. Um, so it's we talked about acid rain. It's a dirty fuel. It produces soot. And then another one, any combustion, any of these fuels also produces the greenhouse gas CO2. Um, and so that again, is a negative for this particular fuel. So, but I guess the big pro is that even though it is dangerous to extract, harder because it's a solid, it is still plentiful, and it provided a much better alternative than wood. So that's why it was used and utilized very strongly. So after coal came petroleum. So petroleum is basically crude oil. So petroleum, crude oil. So crude oil means it's unrefined. And so we're going to go through an example of the refining process and see how from crude oil we can get all the different types of hydrocarbon fuels that we can utilize in different processes. And so this is kind of a misnomer. So if you go to the UK, petroleum or petro is actually gasoline. This is not quite. We'll call. I'm calling it the same thing. We'll refer to crude oil as the beginning. But what happens is, so if we look at this process, we'll give ourselves a little bit of room here. We're going to start with crude oil. That's what we get from extracting out of the ground. And we're going to put some crude oil into a boiler. This is a little higher, so we got our crude oil. It's coming in here. It's going into our boiler. And we're going to heat this up. And it's going to boil. And that gas is going to travel through a tube. And it's going to go. I'm going to bring this down. We're going to have a big tank here. And this is going to have many different layers. So we're going to try to fill all these in. And so what happens is this we're going to put this in here. And so this is a distillation tower. So if you look at these big refinery plants, you might see these big towers. And then they're going to have like basically different levels, different plates that you'll see. So I'm going to draw 1, 2, 3, 4, 5, 6 of the plates. And these are each going to separate out the different hydrocarbons. So we have 1, 2, 3, 4, 5, 6. Okay. And so at the very bottom, we have carbons that are greater than 20. So C20 and above. And we can't do a lot with these. So this is going to be tar. or we could use these in processes such as asphalt. So not really great for energy, but can be used for other things. So compounds between C16 and C20 are too big for anything. So we're going to come back to these. And these actually even so C15 to C18. So they separate out into two different layers. We're going to take both of these and we're going to process them in something called thermal cracking, which allows us to break them into smaller thermal cracking. We're going to be able to, I'm going to complete this around in a sec, into smaller carbon chains. We have C14 to C16. Again, this is the chain length. And this is going to be diesel fuel. So if you ever wonder the difference between diesel and gasoline, diesel is a higher carbon content. We have C12 to C16. We get our jet fuel. And then C5 to C12 is where we get our gasoline. And then, so thermal cracking will allow us to take these C16 or C15 to C20 hydrocarbons, and we can actually, I'll do this in a different color. We can put these as, so thermal cracking will allow us to take these and make them into one of these three. So we really want them to be diesel, jet fuel, or gasoline. And then what we find at the very top of this column is the C1 through C4. So that's going to be they call them refinery gases. Refinery gases. And now, so we have C1 is methane. C2 is ethane. C3 is propane. 4-carbon chain is butane. So I was missing ethane earlier when I had a little brain freeze. If we go all the way down to C8, so that is octane. So you've heard of high octane fuels. That's going to be fuels that have a high proportion of C8 in the gas mixture. So you can see that we have a bunch of different things. Now, one thing I also want to mention is that these refinery gases, so one refinery gas that we really are going to be paying attention to is methane. Methane is a very potent greenhouse gas. And we find that a lot of this methane, or not that methane, a lot of our methane escapes in this refinery process into the atmosphere. And so the processing of petroleum or crude oil actually releases the process of it, not the burning of it, but the process of it releases a lot of greenhouse gas and energy. This is just an overview of petroleum. So now you kind of see where we get the different types of gas and fuels and how those are used. So